Hello everyone, welcome back to our life cycle thinking in energy and environmental systems course. Today we are going to talk about something about waste management. My name is Tang Yuanjun from Zhejiang University of Science and Technology. This presentation will be divided into three parts. First is some brief introduction about municipal solid waste. And then we are going to talk about something about waste management system methods. And then we are going to talk about some life cycle comparison of waste management options. First is some picture about solid waste. As we can see, the widespread disposal of municipal solid waste causes serious environmental problems. For example, it causes air pollution, soil pollution, water pollution, and threatens our health. Then, we are going to say about what is a municipal solid waste. Municipal solid waste is the unwanted or unusable materials that are thrown away after the primary use, so we call it waste. It's something we use it and we throw it away when it is broken or when we don't want to use it. So waste is an unavoidable byproduct of our modern days, our living styles. Waste is generated in our daily life, and waste generation increases with the GDP increases. As we can see, the global municipal solid waste generation in 2020 achieves 2 billion tons, a very huge amount. So, where are waste come from? Waste are generated from several sources, such as domestic, industrial, agriculture, and commercial activities. First is the domestic waste. The waste materials produced from our households in our daily life, and so we call it domestic waste. And then is industrial waste. All industrials generate waste materials. The waste typically includes ash. So, for example, the ash from the power plant, the ash from some chemical processes, and also rubbish, building material waste, toxic waste, metal containers, plastic containers, paints, oils, and other complex synthetic materials. They are all industrial wastes. And then is agricultural wastes. So modern techniques employed in agriculture and the use of a variety of chemicals have contributed to the production of large quantities of agricultural wastes. For example, the byproduct from the rice production. And also, the last one is the commercial waste. A lot of waste is generated from commercial establishments such as restaurants, hotels, markets, offices, and some from hospitals. So they are called commercial wastes. So here is the proportion of different kinds of wastes. So we can see the industrial waste is the most important part of all the waste generated. So domestic waste, which is generated by households collected materials and local government, street sweeping, maintaining, and some from the public parks and gardens. So it includes food waste, containers, for example, the packaging materials, and also yard waste, and other inorganic components, for example, the newspapers, clothing boxes, office and classroom papers, wood pallets, and cafeteria wastes. So waste is generated all around the world. For example, as we can see, we living in a throwaway world. In 2016, the generation around the world, the generation of municipal solid waste around the world is displayed here. So we can see there are some areas that generate a lot of municipal solid waste. Here is the waste generation per person in 2016. As we can see, the color reflects the generation amount of the waste. We can see there are some area generates a lot of waste. For example, in North America, here we have a lot of waste generated, and in some areas in Europe, the personal capture waste generation amount is very huge. And as for the composition of municipal solid waste, we can see the most important part of municipal solid waste is the organic waste, which we also call food waste or food waste here. And then is some recyclables, we call recyclables. For example, the paper waste, the plastic waste, glass waste, metal waste, and other wastes. And from different areas, we can see the OECD area produce the most huge amount of wastes. And then is the East Asia Pacific area, and then some other areas. With respect to regarding to China, in 2022, more than 214 million tons of municipal solid waste is produced in 2022, and the harmless treatment rate reached 99% in China. In China, the annual increase of municipal solid waste is very high. It reached about 4.25%. So the increasing rate is very high in China. Regarding Hangzhou, in Hangzhou, the municipal solid waste generation amount also increases very fast in the past years. Here in 2003, we have 91 million tons of municipal solid waste, but in 2013, we have 300 million tons. 3 million tons in 2013, and in 2018, we have 4 million tons of municipal solid waste generated in Hangzhou, and in 2021, we have almost 5 million tons of municipal solid waste generated in Hangzhou. Also, as we said, the composition or the fraction of municipal solid waste depends highly on the domestic GDP. Also, we can see the proportion of typical components in municipal solid waste varies greatly with the economic development and also the changes in living standards. For example, in 1997, in Hangzhou, the most important part of municipal solid waste is food waste. It occupies almost 60% of all the municipal solid waste generated. But in 2013, the proportion decreased to around 50%. Regarding to the recyclables, which we see they have some value to recover. So, for example, for paper waste and plastic waste and glass waste and metal waste, in 1997, the proportion of these recyclables is very low, but in 2033, the proportion of the recyclables becomes higher. So, with the increase in the social economic and the living standards, the proportion of the recyclables becomes higher in the municipal solid waste. And in Hangzhou, we have two different ways to treat the generated municipal solid waste. One is incineration. We send the municipal solid waste to the incineration plant to combust the municipal solid waste and then generated the electricity and heat. The other is landfill. The generated municipal solid waste was sent to the landfill site and then we burned it. Also in Zhejiang province, in Hangzhou, we start the source-separated generation of municipal solid waste. Municipal solid waste was divided into four different categories. For example, the recyclables, the biodegradable waste, and the hazardous waste, and then the other waste. So when we use the source-separated collection, we can collect different types of waste from the very beginning of the waste collection. So that we can do a better disposal and treatment and recycle of municipal solid wastes. And then we are going to talk about something about waste management methods. So what is waste management? Waste management can be simply defined as the collection, the transportation, the recovery, and the disposal of municipal solid waste. So the whole life cycle of municipal solid waste, from the very beginning of collection, and then the transportation of solid waste from households to the treatment sites, for example, incineration plant or the landfill site. And then the recovery of the usable materials, for example, the recycling of the paper, plastic, and metals. Also, the recovery of electricity and heat by means of incineration, and also maybe some other recovery methods. And then the final disposal of waste. So this is all the life cycle of municipal solid waste. So waste management is the collection, transport, recovery, and disposal of waste, together with the monitoring of the waste management processes. So this is waste management. And for waste management, we have a 7 R's regulation or 7 R's guidelines, which is first, rethink. Rethink means before we produce a municipal solid waste, we should think whether it can be reused or whether it can be used again. So by rethinking, we can decrease the amount of the municipal solid waste generated. So the first R is rethinking. Rethinking about the items, whether it should be or whether it cannot be a solid waste. So first is rethinking. And then is reuse. The reuse of the goods can decrease the generation amount directly of municipal solid waste. So if we, for example, when we have a paper, we use the one side and then we reuse the other side, so we can reduce the generation amount of municipal solid waste. The third R is reduce, which is also means we should try our best to reduce the generation amount of municipal solid waste. The second R is refuse, not reduce. The refuse means we should refuse the generation of municipal solid waste in our daily life. For example, we should keep the things that can be reused. And the fourth one is reuse. The reuse of the items can decrease the municipal solid waste generation amount. And the next one is recycle. For example, when we have some plastic cardboards or some plastic bags, so we can recycle the paper or the plastics or the metals from these materials, so that we can achieve the management of the solid waste and the reduce of the municipal solid waste generation amount. This is recycle. And then regulate. Regulate means we should do all these things in obey the regulation. So we should do it in a right way. And then research. Research means we should do a lot of research about the reduce, the reuse, the recycle, the recovery of municipal solid waste. That we should do the research of the technology, of the regulation of the waste. So this is the 7 R's guideline of waste management. As regarding to the specific waste management methods, the first one is recycling or reuse of waste. Recycling means the conservation of resources in used items by converting them into new products. For example, old newspapers can be recycled to make tissue, paper, and cardboard. So this is the meaning of recycling. So we can recycle some materials from the used items by substitute the raw materials, so we can save the resources. And reuse means conservation of the resources in used items by using them over and over again. For example, glass bottles can be collected, washed, and refilled again. So by reuse of the municipal solid waste, we can decrease the generation amount of municipal solid waste, and also we can save some raw materials. So this is reuse. And regarding to the specific disposal method, first one is the open dumping. Open dumping is prohibited in nowadays in most areas nowadays. And open dumping is defined as a land disposal site at which solid waste are disposed of in a manner that doesn't protect the environment. So it is when open dumping is used for the disposal of municipal solid waste, it can cause serious environmental problems. For example, the soil pollution, the air pollution, the water pollution, and also it may threaten our health. So this is prohibited in most areas in the world. The first one is open dumping, and the second one is open burning. It is also prohibited in most areas in the world. What is open dumping? Open burning. Open burning is the burning of unwanted material in the open air, where smoke and toxic fumes are released into the atmosphere directly, therefore affecting the environment. Often, such practice is done outdoors, where household waste materials are burned as a means of waste disposal, away from an incinerator or a furnace chamber. So, open burning means we burn the burn waste in the open air. So it causes a lot of air pollutants, and also maybe cause some dangerous, the release of some dangerous substances. For example, the release of dioxins and also some bad substances. And here is some functional elements of municipal solid waste management methods. The first one is landfilling. Landfilling means we put the municipal solid waste in a place. We burn the municipal solid waste in a place, in a controlled place. It is different from the open dumping. Open dumping is an uncontrolled method, and landfilling is a controlled method of municipal solid waste disposal. And also, when we do the landfilling, we should capture the landfill gas, which is mainly the methane released in landfill sites, should be captured in the modern landfills that are provided with a gas collection network. This is landfilling. And also we have some recycling, reuse, and composting treatment method. And we have thermochemical treatment method, which is we call municipal solid waste incineration. Incineration is a process that we combust the combustible components of municipal solid waste and then recover the energy from the compostable part to generate electricity and heat during the incineration of municipal solid waste. And some novel technologies, for example, we have pyrolysis of wastes and also gasification of wastes. Here we can see the landfilling of municipal solid waste. The landfilling site of municipal solid waste is some facilities underground and separate the compressed garbage from the surrounding environment. So we use the fumes to separate the municipal solid waste with the surrounding environment. So, for example, the water, the air, and the rain. So we can lower the effect of municipal solid waste on the surrounding environment, and with some special materials. So the characteristics of landfilling is it's a very mature technology and the most important technology all around the world. So it is simple. It can be the operation process is very simple and the construction investment is very low. However, it has some disadvantages. For example, it occupies a large amount of land, and also it is difficult to realize the pollution control, and the environmental sustainability of landfill is very poor. And the other very popular municipal solid waste management methods is incineration. The first incinerator of municipal solid waste were built in England in 1874 and in New York in 1885. Large-scale MSW incinerator was mounted in Hamburg in 1895. The major benefits of municipal solid waste incinerator is it can reducing the amount of waste, which is about 17 to 80% of in mass and 18 to 19% in volume. If compressed, the reducing amounts can reach 19 to 95%. So the biggest advantage of this method is the reducing amount of waste. Waste is significantly reduced after incineration, so we can save the land, save the economic cost of treatment of this waste. And also, it has a significant benefits on reduction of landfill space about 13 times less than landfilling. And also, by incineration, we can recover the energy from the waste, so we can produce electricity and heat in incineration power plants. However, incineration has its own drawbacks. For example, the investment is very high and the operating cost is also very high. And also, we can generate some secondary air emissions. For example, some gas emissions in the flue gas, and also we have some fly ash, which is very toxic. And also, the amount of mass residues and impurities in butane ash should be taken into consideration for further treatment. And also, we have some public views on waste incineration. waste incinerators, so we have some restricted from the public. Here presents some different countries that use different waste treatment methods. For example, in France, the more than 30% of municipal solid waste. In France, more than 30% of municipal solid waste is incinerated, and about 10% of municipal solid waste is recycled. For composting, also 10 to 50%, and around 30% of municipal solid waste is landfilled. In Italy, the proportion is 20 for incineration, and 20 for recycling, and 10 for composting, and more than 40% of the municipal solid waste is landfilled. And in UK and Ireland, the proportion is around 10% of municipal solid waste is incinerated, and 20% recycled, and 10% composted, and around 50% of municipal solid waste are landfilled. Also, in some other countries, for example, in China, this data is at around 2010. In 2013, around 15% of waste in China is incinerated, and 15% recycled, and more than 60% of municipal solid waste is landfilled. However, in 2022, the proportion becomes more than 70%. More than 70% of municipal solid waste in China is incinerated, and only around 24% of municipal solid waste is landfilled. And in China, in 2022, the proportion becomes 70% incinerated and 20% landfilled. Here is the waste generation methods in China in recent years from 2009 to 2018. As we can see, the proportion of waste of this is landfill, this is incineration. The proportion of incineration becomes higher and higher in the recent years. As we said, in 2022, the proportion of incineration becomes more than 70%, and for landfill becomes less than 30%. Here is the picture about the problem caused by solid waste. As we can see, the man said the impact of municipal solid waste doesn't look too bad. As we can see, it is not very bad. It is only a very small impact here. However, the situation of solid waste is like this. This is only we can see. This is the only we can see. The small part we can see. However, we have a very huge impact under the water, so we can't see this. We have some solid waste problems. We have air pollution problems. We have some GHG emissions, greenhouse gas emissions problems here. We have the problems is the impact is very huge. And then we are going to talk about something about life cycle comparison of waste management options. First is some review of our previous courses. What is life cycle assessment? Life cycle assessment is an environmental management tool that assesses the overall energy use of environmental impacts of a process, a product, or an activity over its entire life cycle, from raw materials acquisition to the final disposal. For example, for municipal solid waste management, the beginning is from the raw materials production and then the generation processes, and then the package and distribution processes, and then we have some usage processes and the waste processes. The waste generation processes here, and then the collection of the waste, and then the sorting and recycling of the waste, and then we have the energy from the waste by incineration or by composting, by anaerobic digestion, some other methods, and the final disposal of the solid waste. So this is a picture of the idea of life cycle assessment of municipal solid waste. And also, previously we introduced how to conduct life cycle assessment. The first is the goal and scope definition of the life cycle assessment work. First, we should define clearly what is the product, what is the objective, and what issues to be solved, what do we want to do, and who will be the beneficiary. First, we should define the goal and scope of the life cycle assessment work. And the second step is the collection of the modeling data. For example, the extraction of the materials, the production, the transportation, the use, the disposal stage. We should collect all the input and output energy and materials data. For example, the energy and materials input, the air emissions, water emissions, and soil emissions output. We should collect all the process data. And then we should convert all these input and output data to our functional unit. Functional unit means we should have a calculation basis. For example, we want to have some CO2 emission data, we want to have some NOx emission data, SO2 emission data, and so on. The second step is the establishment of the life cycle inventory analysis. We connected all the input and output data and convert this data to the functional unit databases. And then we categorize all these emissions into different categories. We classify all these emissions into different categories. For example, we should put the CO2 emission, CH4 emission, CFC emission into global warming potential category. And also we have some acidification potential category. We put all these emissions into different environmental impact categories. This is the life cycle impact assessment. For example, for the global warming potential impact, we know that 1 kilogram of CO2 equals to 1 kilogram of CO2 equivalent, and 1 kilogram of CH4 equals to 25 kilogram of CO2 equivalent, and 1 kilogram of CFC equals to 10,900 kilogram of CO2 emission equivalent. So we should convert all these emissions into the same units. For example, kilogram CO2 equivalent. This is the life cycle impact assessment method, the stage. After that, we should classify the impact indicators into different categories. For example, we should put global warming to human health. For example, ozone depletion to ecosystem quality. We put all these impacts into different categories. And normalization all these categories into a normalized results, or we can see its overall indicators. So this stage is the life cycle impact assessment stage. Last but not the least, the next one is the interpretation of the results. So we should compare the goal and scope definition and the interpretation stage. So in the goal and scope definition stage, we define what we want to do, and in the interpretation stage, we should make some suggestions, make some improvements, and make some conclusions and comparisons of all of the life cycle assessment results. So this is the whole stage of the life cycle of how to conduct a life cycle assessment as we previously introduced. And then we are going to talk about one life cycle assessment case studies we conducted in 2013, and it's about the municipal solid waste self-separated collection and integrated waste management systems in Hangzhou, China. It's a case study here. The first is the municipal solid waste generation systems in Hangzhou in 2010 and 2011. There are 2 landfill sites and 4 incineration plants in Hangzhou, and MSW is mixed collected in 2000 and in the past years. In 2010, around 50% of the municipal solid waste is sent to landfill, and the balance of 49% of municipal solid waste is disposed by incineration plant, is treated, is recovered in incineration plant. And also, the self-separated collection is started. MSW is classified into 4 categories. As we said, 4 categories include food waste, recyclables, hazardous waste, and other waste. The self-separated collection efficiency of different components of the municipal solid waste are 25% for food waste and 70% for recyclables. And we can see some characteristics of municipal solid waste. First is the food waste. The proportion of food waste in 2010 is around 60%, and the moisture content of food waste is as high as 70%. And the recyclables for paper, plastics, textiles, and glass and metals, the proportion of these recyclables is also presented here. And the municipal solid waste treatment methods or treatment systems are divided into 4 scenarios. The first one is MSW mixed collection system. So all MSW is mixed collected, and 50% of the waste is disposed in landfill site, and the remaining 49% was sent for incineration. And the scenario 2, the second scenario, represents the current MSW management system, which means both MSW self-separated collection and mixed collection are worked in this case. Food waste is landfilled separately, and recyclables are delivered for reprocessing and recycling. The residue MSW is incinerated professionally, whereas the surplus amount is disposed in landfill site, and this is the second scenario. And the third scenario is a short-term MSW management system, a short-term MSW management plan system. So this is according to the city's 2-year plan. A new incineration plant with a daily capacity of 1,200 tons per day will be built in the near future. So the yearly operation time is assumed to be 300 days, and will substitute an equal amount of municipal solid waste disposed for landfill. And then is the last system called a long-term municipal solid waste management plan system. So this is according to the 25-year plan of the city. So food waste will be delivered step by step towards recycling, and biological treatment is under consideration. So, which means the composting and anaerobic digestion methods will be introduced to the waste management systems. So here is the system boundary of this study. So we can see we have the generation and the collection of municipal solid waste, and the municipal solid waste have two collection methods, which is mixed collected waste and separated collected waste. For mixed collected waste, the waste is sent to incineration plants and landfill sites to generate electricity and energy use. For source-separated collected waste, we have different types of waste collected, which is food waste sent to landfill sites, recyclables sent to recyclings, and hazardous waste to safety disposal. For other waste, it is sent to incineration plants and landfill sites. And all the energy and the materials used in the system are considered in this system. Also, we have some output of the system. For example, the electricity, the compost from composting, and the materials from the recycling system. And also, we have some emissions from the incineration plant, from the landfill site, from the recycling processes, and from the safety disposal processes of hazardous waste. So this is the emissions. All these input, energy, and materials, and output products, compost materials, and emissions are collected. All this data are collected and then converted to our functional unit, and then we calculate the life cycle data of the, we established the life cycle inventory of the processes, and then we have the life cycle assessment of the whole systems. Here is the impact method, which is we can see is based on the EDIP 1907 method. The environmental impacts considered here is the global warming potential, the acidification potential, the nutrient enrichment potential, and the photochemical ozone formation chemical. These four environmental impact categories. And the unit is presented here, and the contributor substance is presented here, which means we see the CO2, the fossil CO2 and CO and the methane and N2O are contributors to global warming potential. So we should collect all this data in this category, and also we have equivalent factor of these different emissions. For example, 1 kilogram of CO emission equals 2 kilogram of CO2 equivalent, and 1 kilogram of methane equals to 25 kilogram of CO2 equivalent. So this is the equivalent factor here. And also here we present some results of the case study. The first one is the comparison between the scenario 1, and the scenario 2. We can see emissions and their contributions to each impact category are distributed over the 4 processes or 4 life cycle stages. The first one is transportation, and then landfill, and then incineration and materials recycling. Results show that all environmental impacts have a remarkable decrease after source separation. As we can see, after source separation, all the total emissions have a remarkable decrease of the system. For example, the first one, global warming potential, is 1.15, and after source separation, the total emission becomes 0.81. So there is a remarkable decrease after source separation collection of municipal solid waste. And compared with MSW mixed collection, around 30%, 80%, 28%, and 30% impacts of global warming potential, acidification potential, nutrient enrichment potential, and POF has been saved. So we can see a remarkable decrease of all these different environmental categories. And global warming potential and POF are principal contributors that are affected by both scenarios, whereas negative values appear for AC and nutrient enrichment. So we can see for global warming potential and POF, we have a positive effect. So which means we caused some environmental impacts. However, for acidification and enrichment categories, we have negative impacts, which means we saved the environmental impacts because of incineration technology. And also, the environmental savings are primarily attributed to energy recovery from incineration and from landfill by landfill gas to electricity, and both from landfill gas combustion and waste incineration. After source separation collection, all the environmental impacts, all the four considered environmental impacts are remarkably decreased. And then we have a comparison of the different scenarios of landfill and incineration. By these two different technologies, incineration exhibits a better environmental performance than landfill for all the investigated impacts. As we can see, here is the incineration results, and this is the incineration results. For example, for global warming potential, we have 87 results for global warming potential for landfill. However, for incineration, the impact becomes 2.75. So this is a remarkable decrease, a significant decrease. All the environmental impact categories are decreased from the incineration compared to landfill. And with regard to each contribution stage, the environmental advantages of incineration mainly come from the energy recovery. So the electricity production from incineration causes we say is the main contributor to the decreases of the environmental impacts. And fossil-derived carbon combustion is the main reason for CO2 generated from incineration. And landfill poses a higher global warming potential figure than incineration due to the large quantities of CH4 of methane released. As we know that during landfill, a huge amount of methane is produced in landfill sites. Some of the methane is captured to combust it and generate electricity, and some of the methanes are released, so it causes a huge amount of global warming potential. And the same reason can explain the high POF from landfills, since methane is also a main contributor of the POF related emissions. And then we compared two different source separated collection systems by introduce the technology of, for example, composting and anaerobic digestion. This is the source-separated food waste is stand for biological treatment of landfill according to the city's long-term municipal solid waste management plan. So scenarios 4A and 4B represent the municipal solid waste, considering the composting and anaerobic digestion respectively. So as we can see, both these two different kinds of technologies have good effects on the environmental pollution production. So the composting is also seen to have adverse environmental impact to acidification and nutrient enrichment processes. And environmental performance of scenario 4B, which is anaerobic digestion, is the best among all the scenarios, which means an additional 75% of global warming potential, 4% of acidification, 14% of nutrient enrichment have been reduced compared with scenario 3, and the environmental loading has turned to environmental savings with regard to POF. So in scenario 4B, the POF, the environmental impact of POF turned from loadings to savings, which is very important saving. The environmental advantages can be explained by twofold reasons. Firstly, by use of AD, methane is utilized for energy recovery. So the exploration of fossil fuels is saved. This environmental savings can be achieved if composting is adopted. Secondly, AD reactor can easily reach a higher methane collection efficiency than the landfill sites. So we have, furthermore, compost is produced both in case of composting and AD, which can be used as soil conditioner and therefore avoid the emissions from material-based fertilizer production. So here is a case study of life cycle assessment of municipal solid waste management. In our previous studies, we introduced something about the system, about the methodology, about the results. Here is a brief introduction about the life cycle assessment case study of waste management options. Also, we compared different thermochemical systems of waste management different thermochemical waste management systems based on pyrolysis, gasification, and incineration WTE technologies. For example, here we have the municipal solid waste. It can be incinerated directly, and also it can be pyrolysis after drying, gasification after drying. For incineration, the product is heat and electricity. For pyrolysis and gasification, the product is the syngas, tar, and char in different ways, in different utilization methods. So thoroughly, we conduct a thorough comparison of municipal solid waste pyrolysis, gasification, and incineration, based both theoretical analysis and case studies for commercial plants. The aim of this study is to optimize the environmental, optimize the process optimization to be more environmental sustainability. So we have two sets of data. One is the theoretical analysis of different WTE systems using data obtained from the EU system. So the potential to lessen environmental loadings. One is an improved energy recovery efficiency. The higher the energy recovery efficiency is, the higher the energy savings, the environmental savings can be obtained. And also, the second way is to reduce the process emissions. The lower the process emissions, the lower the environmental loading is. And the set 2 is the compare of some commercial operation WT plants using data from industrial practice of pyrolysis, gasification, melting, and modern incineration plants. And the results review a preferable performance of the gasification plant is observed, and also the incineration behaves environmentally sound, attributed to modern flue gas cleaning using, for example, CHP to increase the energy recovery efficiency, and ash cycling to also increase the energy recovery efficiency. Flue gas cleaning to reduce the process emissions. So this is the two main methods. One is the increase of the energy recovery efficiency, and then is the reduce of the process emissions. Also, we compared some commercial WT technologies. The first one is gasification plants in Finland, and the second one is a great incineration plant in France, and the third one is a conventional incineration plant in China. And the results review a superior overall environmental performance of gasification system is observed due to the syngas cleaning system and for both process emissions reduction and energy efficiency improvement. So the choice of process permits is critical to the molding results, and the development of specific WT technology highlights both technical and graphic factors. For example, we concluded that CHP can serve as a practical option in areas with high heat demand, and improvements in China can be use of the source separated waste, and also improvements in France, the recovery of metals and road construction materials from the molten ash. Here are some case studies of life cycle assessment of waste management options. So thank you very much for your attention, and that's all for today's class. Today we talk about something about the life cycle assessment or life cycle thinking of different municipal solid waste management options. That's all. Thank you.